Hi, and welcome to this Microsoft Virtual Academy course on SQL Database Fundamentals. I'm Graham Malcolm from Microsoft, and I'm joined with my colleague Chris Randall here. Chris?
Hi, I'm Chris. I'm a Senior Content Developer with Microsoft, or as we say around here, same as Graham.
Yeah, exactly. Yeah. So there's a slide that we're showing here with some information about Chris that tells you a little bit about his background. There's a very nice picture of his dog as well. If you're confused about that, Chris is the one on the left. And there's also a rather nice slide with me looking kind of cool and relaxed, which is not really how I normally feel.
No, well, I couldn't find one with sunglasses, so that's why I picked the one with my dog.
Yeah, I never get enough good weather for that. So that's us. That's pretty much all you need to know about us. Really, the important thing that we're going to talk about today is we're going to talk about working with databases. So we're going to spend a little bit of time just giving you a kind of introduction to databases and some of the concepts. It should be pretty interesting. All right, Chris, you want to lead us through what we're going to talk about?
Sure. So this course is broken out into half a dozen modules, such as this brief introduction, which will roll right into our getting started with tables. We'll talk about the structures of database tables and where they live and why you need them. We'll talk about how to get data into them, how to get data out of them, how to make changes. And then we'll move into sort of the system support for databases. We'll get into topics like indexes and other things that are used to optimize databases. We'll talk a little bit about different data types that are native to SQL Server and relational databases, and then we'll move into non-relational database and other types of data that we might store. And then we'll finish up with a brief look at the kinds of things that a database administrator, or a DBA, performs on a regular basis. Graham?
All right, yeah, that sounds like a pretty packed schedule. So as you say, let's roll right on in there and start with an introduction to what databases are and what kind of things we can do with them. So I guess when people think about data, a lot of people who are familiar with working with tools like Excel, for example, probably think about something that looks a bit like this. You might think of data that looks like a table of data in something like Excel. So
widgets and thingy-bobs and knickknacks.
Widgets and thingy-bobs and knickknacks. So you can imagine that somebody who's keeping track, perhaps you're a small company, perhaps you're just keeping track of some stock, you might do something like this. Now, technically, I guess you could say that's sort of a database. There's certainly data there.
Well, Excel is the world's most popular database, isn't it?
Indeed it is. Excel is the world's most popular database. It's perhaps not the most efficient way to store that data. So I want to kind of walk through some of the limitations of storing data in a table, in a spreadsheet like that. So let's take a look at some examples here. So here's that data in a table form. We're taking it out of the spreadsheet here. We've just got that same table of data. Can you see anything that's perhaps a bit funky about that, something that's not great?
Well, I'm looking at that column for color, and I'm seeing that there's multiple values in a couple of those rows. We've got blue and red for thingy-bob. We've got red and black for knick-knack.
Right, exactly. So I mean, obviously the intent here is that thingy-bobs are available in blue or red. So for color, we've stored two values in that one column. Now that's not ideal. We really want to be storing just one value in each column. So what we want to do is go through a process. Technically, the process is called normalization. You won't be quizzed on that later, so don't worry too much about that. But we're going to use a process called normalization. And the first thing we need to do is put this data into what we call first normal form, is the technical term. And what that really means is we shouldn't have any columns that have more than one value in them. So let's take a look at how we do that. And we'll just animate this table. You can see there's the columns that are problematic. We've got those double values in there. So what we'll do is we'll just split those out, and we've now got separate rows. So we've satisfied first normal form. Each column supports only one value. But there is still kind of a few problems with this. And I'm looking particularly at the supplier. What can you see there that might be an issue for me?
Well, I see some redundancies. I see the same supplier stored in multiple rows. We've got Contoso 3 times, Northwind twice.
Exactly, yeah. So we've got data there that's stored in multiple rows, as you say. It's duplicated. And of course, that means if I ever had to change, if Northwind changed their name, I'd have to actually go and change it in each of the rows where it appears. And that's pretty inefficient. And I'm using up more space than I necessarily need to store the data. So at this point, we want to move into what we call second normal form, where we start separating those values out into separate tables, and each table represents an entity in my database. So I can go ahead, I can see there's the problematic column. I can go ahead and I can split that out, and now I've got a product table and a supplier table. And I've assigned a unique ID to each supplier, I've assigned a unique ID to each product, and I'm using the ID for the supplier in the product table to say, hey, this is the supplier for this product.
And we could even do that with some of the other columns, couldn't we? We could do that with color.
Yep, absolutely. We've got the same problem with color. So we can go ahead and we could do that. And again, we split that out. So we've now got our color table and we've got our product table. Now, we're not quite there yet. There's a few other issues we need to deal with here. So let's just have a look at this problem here. We've got the color ID and we've got the product ID, but there's nothing that says which color is which product. All right, so we have a bit of an issue there. Now, there isn't really a business entity that we can use to deal with this, but we can create a table. Effectively, it's a table that just enables the join. It's a nice, efficient way of saying, here's a table that joins the product table to the color table, kind of intermediary table.
So it maps between them.
Yeah, a mapping table is a good way of thinking of that. So I've now taken my data that was originally just a table in Excel, and I've split it out into multiple tables, and I've joining them based on keys. So it's beginning to look much more like what we would think of as a relational database. There is still another problem. Can you spot the other problem here?
Well, if we go back to the original product table, we don't see a connection, do we? Let's see. We've got product to our color. We don't have product and supplier.
We don't have, well, we've got
that's true. We do have that directly in the column.
I'll give you a hint. Does a product have a phone number?
No, nor do phone numbers have that many digits, but we'll give you a pass on that.
We'll ignore that for the time being. But products don't have phone numbers.
That's right.
So we've got phone in there, but that really isn't related to a product. That's actually something to do with the supplier.
Right.
So we have this concept of making sure that all of the columns in a table depend on the primary key for that table. They all depend on what that table is about. So in this case, products don't have phone numbers. Really, that whole column should be moved across to the supplier table because suppliers have phone numbers. And in doing that, we reduce a bit of redundancy as well because we've now got the telephone number for each supplier in the supplier table. So this is now in what we call third normal form. Now, there are a whole bunch of other higher level normal forms we could go into and wax lyrical about. We don't need to do that. For our purposes in a database, usually third normal form is pretty much as far as we need to go. But what we've now got is a database that consists of multiple tables with keys that identify uniquely each row within each table and foreign keys in the other tables that we can use to relate one table to another.
And we've removed redundancies.
Yep.
We made it easier to update. Is it any faster to query?
Not necessarily any faster to query. In fact, in some ways, it's going to be more complicated now because we're reading from more tables. So later on in this course, we're going to look at ways that we can optimize queries for dealing with these tables. But for the time being, we've now reduced the redundancy. We've got a pretty efficient way to store our data. So we can think of what we've done as being creating the database, what we'd call the schema of the database, effectively the tables that are in the database. We need to think about how that database is actually stored. And what we do is we take that and we store it on disk in something called a database management system. So it's on a server, really. Typically in an organization, there's a computer that's the server, and it's running some software that's a database management system. And examples of that are things like SQL Server. Microsoft SQL Server 2016 is our latest version of a database. There's also the option to perhaps connect to that database from various different clients over a network, which is typically how people access them. And of course, that may not even be on the same local network. It may be in what we call the cloud. It might be hosted on an internet service somewhere like Microsoft Azure. So I could have a virtual machine in Azure that's running SQL Server, or I could use something like an Azure service. There's an Azure SQL database, which provides me with a database system in the cloud. So we've got this idea of having the data stored in that schema on disk in a database system that's accessed over the network from various different clients. Make sense?
Sure.
So one of the things we might want to think about when we're accessing that is, of course, some sort of security. So typically, if we're accessing something in the internet, not necessarily just on the cloud, even internally on a network, you might have something called a firewall that limits the clients that can actually connect to it. And you'll certainly want to have some sort of identity check, some sort of authentication that makes sure that people are connecting who are allowed to connect, and that anybody who isn't allowed to connect is forbidden from getting to it. So there are some other considerations that we need to think about, and we'll talk about those later on when we look at the admin of this. But that's kind of how the system works. Well, now that we understand a little bit about the concepts behind this, we know a little bit about database schemas, we know a little bit about the way a database server works, why don't you jump in the driving seat and actually show us how we can see a database being created and managed?
Sure. Let's take a look at the demo.